Okay, so for part B, we have a proof by mathematical induction, and guys, I'm not going to lie, this is hard. This is a difficult one. I always say that my favorite ones are the differentiation proof by induction. That's still true. I enjoyed doing this question, but it's difficult. So let's go through it. Step one is, so it's always the same steps. Prove true for n equals 2, because here, guys, it's saying we're proving for integers for n is equal to 2. So that means the second derivative of x should equal this. But we know the second derivative of x is equal to 1 over, negative 1 over 4 root 1 plus x cubed. So this, if you like, is the left-hand side, is this. And then the right-hand side, let's actually put these on the left. Let's put this here. I'll put this on the right. So the right-hand side will be when I sub 2 into here. That would be minus a quarter to the power of 2 minus 1 times 4 minus 3 factorial, because I'm subbing in 2 in here, over 2 minus 2 factorial, subbing in 2 in there, times 1 plus x to the half minus 2. And this is equal to minus a quarter to the power of 1. This is 1 factorial and this is 0 factorial. 1 factorial is 1 and 0 factorial is 1, so that just disappears. And this is going to be, well, let me just put times 1 times 1 plus x to the power of minus 3 over 2. And this, we know, guys, equals this minus 1 over 4 times the square root of 1 plus x cubed. Left-hand side equals right-hand side. Therefore, true for n equals 2. Okay, step 2. Step 2, let me just, guys, copy this down because I'm going to need more space, just so I can see it. Okay, step 2. Assume true for n equals k. So that means the kth derivative is equal to minus 1 over 4 to the k minus 1 times 2k minus 3 factorial over k minus 2 factorial times 1 plus x to the half minus k. So that's easy. We've assumed true for that. So that's 2 marks in the bag, not that difficult. This is where it gets, well, this is where all proof by induction questions get difficult. We need to prove true for n equals k plus 1. Okay, so I like to put in this step, guys, and I think it's important. Trying to show. So we're trying to show that f of, well, the k plus 1th derivative, so the next derivative of this, or the derivative of this, is equal to minus 1 over 4. So I'm going to do k plus 1 minus 1, which is just k. I'm going to do 2 to the k plus 1. Okay, I'll do this in 2 steps. So it's 2 to the k plus 1, so I'm subbing in k plus 1 for k, minus 3 factorial, all over k plus 1 minus 1. I'll do that like this, k plus 1 minus 1 factorial, all to the power of 1 plus x to the power of a half minus k plus 1. And this equals minus a quarter to the power of k. 2k plus 2 minus 3 is actually 2k. 2k plus 2 minus 3 is 2k minus 1 factorial over, sorry, that was a 2, guys, sorry. It's k plus 1 minus 2. So that's k minus 1 factorial. And this is 1 plus x to the power of, well, it's a half minus k minus 1, which is minus a half minus k. Okay, so that's what we're trying to show. This, and I'll always keep this in mind as my target, because we're going to go back now to this. So I'm going to say, let me slightly cheat, guys, and just copy and paste this, but I want you to always write this out. So we know the kth derivative is this. So the goal of these differentiation proof by inductions is to differentiate this, differentiate the kth derivative, use your assumption, and get this, the thing you're trying to show. So that's all we're trying to do. I'm going to differentiate that and get this. Now it doesn't look that bad, because well, you're going to get this is going to come straight away. Where it becomes difficult is with the factorials, but I'll get to that now in a second. So the next derivative, the k plus 1th derivative, is equal to, so these are all just constants, guys. So minus a quarter, or they behave like constants, k minus 1, 2k minus 3 factorial over k minus 2 factorial. So when I'm differentiating, I'm just worried about this 1 plus x thing. So I'm going to multiply by the power. So I multiply by this. This is the power, a half minus k. Multiply by a half minus k, and subtract 1 from the power. So it's 1 plus x to the power of a half minus k. Sorry, a half minus k minus 1. So I subtract 1 from the power. Now that is, that's good, because we have this part here already. Fine, right. So now we need to turn this into this, and it looks complicated. Let's look at what we have. So this, what we're trying to get is a minus a quarter to the power of k, and we have a minus a quarter to the power of k minus 1. So the kind of natural thing to do, guys, is get this minus 1 out of here. So now I have minus a quarter to the power of k times minus a quarter to the power of minus 1. That's fine, because if I add my powers, k minus 1, I get this. So I've just kind of taken it out, which is nice. And the rest, well, for now, it's going to have to stay the same. 2k minus 3 factorial over k minus 2 factorial times a half minus k times 1 plus x. And now I'll just change this into minus a half minus k. So this is good. I don't need to worry about this anymore, because it's the same. And I don't need to worry about the minus a quarter to the power of k, because that's the same. What I need to worry about is this bit here, the middle 3 expressions, if you like. I need to turn them into this. Okay, so this is minus a quarter to the power of k. Now minus a quarter to the power of minus 1 is actually minus 4. This is minus 4. I'm going to move this over here. So this is going to be, and I'm going to call it minus k plus a half. I'll show you why I'm doing that in a second. So this is minus 4, because that's what the power of minus 1 does. This is just minus k plus a half, obviously. This is the same. 2k minus 3 factorial, k minus 2 factorial, And then this is nice because it's what we want. Minus a half minus k. Okay, next thing. I'm going to show every single step here, guys, just so, because it's hard. And just so it's all crystal clear. Now, I'm going to multiply out these powers, but I'm actually just going to multiply out the minus 2. So I'm going to, instead of minus 4, I'm going to put 2 times, and I'll show you why I'm doing this in a second, 2 times 2k minus 1. So guys, look, if you multiply this out, you get 4k plus 2. If you multiply this out, sorry, you get 4k minus 2. If you multiply this out, you get 4k minus 2. Now the reason I'm doing this is because I'm trying to get 2k minus 1 factorial. And here I have a 2k minus 1. So it's at least heading in the direction of 2k minus 1 factorial. It's not there yet, but it's heading in that direction. The 2, well, this actually does become useful in a second, but just forget it for now. My goal here was to get the 2k minus 1. So now I have 2k minus 3 factorial over k minus 2 factorial times 1 plus x to the minus a half minus k. Okay, now again guys, I'm going to move this down just so I always have it in my view. So I'm just going to leave it here. I'm always looking at this to think, how can I get to this? Okay, so I want 2k minus 1 factorial. So I have my minus a quarter to the power of k, which is fine. I have my 2, which is fine for now. Now, I have 2k minus 1 and I have 2k minus 3 factorial. To get 2k minus 1 factorial, I need to multiply by 2k minus 2. So the reason for that is, well, imagine I had 6 times 4 factorial, and I wanted 6 factorial. Well, if I multiply this by 5, now I get 6 factorial, because that's 6 times 5 times 4 times 3 times 2 times 1. So I'm missing the 5 here. Similarly here, this is my 2k minus 1. Similarly here, I'm missing the 2k minus 2. So let me just put the 2k minus 3 factorial here. So this is like my 6 factorial times 4 factorial, if you like, if you want to think, this is just an example. 6 times 4 factorial. I'm missing the 5. I'm missing here the 2k minus 2. So I'm going to multiply by 2k minus 2. But obviously, if I can't just multiply something by 2k minus 2, I need to multiply above and below by 2k minus 2. Okay, hopefully this makes sense, guys. Now I can write these three expressions here as 2k minus 1 factorial. Let me get rid of this. The 1 plus x to the minus half minus k is absolutely fine. Okay, nearly there, guys. Minus a quarter to the power of k. Now, see this 2 here? This is going to nicely cancel with one of the two, well, the 2's here. I'm going to divide this by 2. So let me actually show you that. So I'm going to cancel, 2 goes into that there, and 2 goes into this here, so I'm left with k minus 1. So this is, the 2 is gone, and I'm left with 2k minus 1 times 2k minus 2 times 2k minus 3 times 2k minus 4, which is all, and continued on, which is all 2k minus 1 factorial. Those 3 there are 2k minus 1 factorial. And then the bottom is now k minus 1 factorial, because this is k minus 1 times k minus 2 times k minus 3 times k minus 4, because that's factorial, which I can write as k minus 1 factorial. Okay, and then this, well, we're done, because look, I have my 2k minus 1 factorial, I have my k minus 1 factorial. I have my 1 plus x, I have my minus a half to the minus k, which we have shown it is true. So therefore, true for n equals k plus 1. I am going to, guys, get rid of this just so I can write my final step. So step 4, don't forget this, guys, for your final mark. I'm going to say it is true for n equals 2. And then if true for n equals k, then true for n equals k plus 1. Therefore, by the principle of mathematical induction, because you write out the 3 words in an exam, by the principle of mathematical induction, true for all z, or for all n where n is an element of the integers and n is greater or equal to 2. Okay, that's obviously, guys, a long video, a long question. I went through it really in detail. I showed you every single step, just so it's all crystal clear. Yes, a question might be, how am I expected to do that in an exam in 10 minutes? And the answer is, well, it's the last question, and it's a hard question there for a reason. If you're trying to get a 7, yes, you want to be able to do that in 10 minutes, but ideally you get the other questions done more quickly, so it gives you more time for the harder questions. Anyway, one more part to go. I'll do it in the next video.